Hey, I want to help you out a little bit with homework number 35. In case you're struggling, this is graphing logarithmic functions. And I have a question for you. I'll just pull one of them straight out of the homework. And I have a few hints to drop to you, and that'll help you get through the homework. So in this particular problem, they want us to graph the function log base 1/6 of x. Now, anytime you're graphing logarithms, I have some hints for you. The first hint is substitute x is equal to 1. Because we know that any time you take the log of 1, no matter what the base is, whether it's 1/6 or it's base e or base 10, it doesn't matter, the log of 1 is 0. So you would evaluate y equals, remember I'm just changing my f of x to y, log base 1/6 or whatever your base is of 1, and that's equal to 0. We always know that, okay? So now we have a point that we can plug in, which is 1, 0. In the homework, you're often given that point already, but not necessarily, okay? That's hint number 1. Hint number 2 is substitute the base. All right, so in this particular problem, that would be y equals log base 1/6 of 1/6, okay? Now, anytime you take the logarithm of the base, the answer to that is 1. If you need to remember why or understand why, if you rewrite this expression as an exponential function, remember to do that, you start with a base, so you have 1/6 to what power, that's the y value we're looking for, is equal to 1/6. So we know that in this case, y, the exponent, must be 1. And remember, a logarithm is an exponent. So we know that our answer, or our point that corresponds to this particular value, is x is 1/6 and the y value is 1. Now here's the problem with that hint for this particular problem. Whenever your base is a fraction, like we have here, and to me these are the worst of the problems, Knewton Alta does not want you to graph fractions. It's a programming issue. It's not that there's any issue about graphing fractions in general. If you were doing this on paper, we could totally graph that point. But in Knewton Alta, graphing fractions is a challenge because it's a programming issue. So we're going to not use that hint for this particular problem. So I have a third hint, and this third hint really only applies if you have fractions, like in this case. So if you have a fractional base, okay, substitute in the reciprocal. Okay, well, what's the reciprocal? Well, the reciprocal, let me say, of the base. Let me make it clear. The reciprocal of the base. So the reciprocal of 1/6 is 6. So I'm going to substitute x equals 6 into this problem. Okay, now I'm going to go another page so you can see it clearly. So I have y, I'm not going to do it that way. So y is equal to log base 1/6 of 6. This is what I'm trying to evaluate. Now watch what happens when I evaluate this. Again, if you evaluate a logarithmic function and you don't have that function in your calculator where you can substitute in any base that you want, if you just have an ln button and an log button, remember ln is a log base e, and a log button is a log base 10, then you need to have a way to evaluate this. And the way to do that is to change it to exponential form. So you start with the base, which is 1/6, to a logarithm is an exponent. That means that y value is an exponent, equals, okay, the argument, which is 6. Now to simplify this so I can figure out what y is, I need these as a common base. So I write 1/6 is 6 to the negative 1 to the y value equals 6. And of course this is 6 to the first if you need to see that. Now if you have a power to a power, remember to simplify this, I multiply. So now I have 6 to the negative y equals 6 to the first. Once your bases match, then you can set the exponents equal to each other. So I have negative y equals 1. To solve for y, that gives me y equals negative 1. So I have y is equal to negative 1 in this case, and if I plot that point, that's going to be the point. 6 was my x value, negative 1 is my y value. Okay? So that's what's going to happen every time. Anytime you have a fraction here and you plug in the reciprocal, your answer is going to be negative 1. And that's probably what you're missing. If you're struggling with this section, that's what you're missing. And I know my lecture doesn't address that because it's unusual for those kind of problems to show up, but Knewton Alta likes them, so we need to have an extra help session for this. Let me put it on another page. I'm going to graph this by hand, not in Knewton Alta. You can figure out how to graph it in Knewton Alta. It's about sliding a point around or 2 points around to meet your needs, but I'm just going to graph it by hand. So remember we had 3 points. We had a point 1, 0. We had the point 1, 6, 1, which you can't plot Knewton Alta, and we had the point 6, negative 1. Okay, so the point 1, 0 is right here. The point 1, 6, 1, okay, is going to be about right here, is about the best I can do with that 1, 6. And then the point 6, negative 1 is over here. And notice that's going to give me the logarithmic function that looks similar to that. But again, in Knewton Alta, you know, I think you're given this point right here, and then you slide around to get to that point, and then boom, you're done. Listen, I hope that helps. If I need to address another one, let me know. Send me your homework question, and I'll make another video. But I think those 3 hints that I'm going to click right back to. Hint 1, substitute x equals 1. Hint 2, substitute the base, unless the base is a fraction, and then Knewton Alta doesn't want you to do it. But it's worth doing it so you can check your graph, you know. And then hint 3, plug in the reciprocal, but you only need hint 3 if you have a fractional base. Good luck. Shout out to me if you have any issues. I hope you have a wonderful day.